Welcome, geometry students. Today we're going to learn about the target, which states find angle measures in polygons. First of all, you need to know what a polygon is. A polygon is a closed two-dimensional shape with three or more straight sides. Now, when we hear the word straight, we often think of a straight line. So the same is true here. We can't have any curves or circles or semicircles in our polygon. So we're talking about a shape that's closed, it's two-dimensional, and its side lengths have to be segments, so straight line segments. A regular polygon now is a more particular type of polygon. So it has all of those same traits, but in addition, it's a polygon with all equal sides and all equal angles. Something I'd like you to put over in your annotations is the difference between equilateral and equiangular. So go ahead and add this in your annotations, please. So equilateral versus equiangular. So if we think about lateral, the root of that word is sides, and equa, the prefix, means equal. So this is a polygon with all equal sides. And when we hear the word equiangular, the root angle, angular means angle, and equa again means equal. So it's a polygon with all equal angles. So you might see those words separately. But when you see the word regular, keep in mind that means all equal angles and all equal sides. Both of those have to be fulfilled. All right, so here it asks us to name the polygon given the number of sides that it has. So we're pretty familiar with things like three-sided. Three-sided polygons would be a triangle. Four sides would be a quadrilateral. Quad meaning four. Five sides, think about the building, pentagon. Five-sided figure. Six side is a hexagon. Seven side is a heptagon. Heptagon. Now the way I remember the difference between these two is six, the number six has an X in it, and hex has an X in it as well. So hex and heptagon are very similar sounding, so just be careful not to confuse those. Eight-sided is like our stop signs, so octagon. Nine-sided is a nonagon. 10-sided is a decagon, I apologize, decagon. And 12-sided is a dodecagon. Now you might be wondering why we skipped 11. There's really not a formal name that you need to know for an 11-sided figure. So we would call any other sided figure, meaning any other polygon, an n-gon, which means n is just the number of sides. So if you wanted to identify the name of an 11-sided figure, for example, we would call that an 11-gon. A 36-sided figure would be a 36-gon, and so forth. So there are other polygons with specific names. We just don't need to know those. These are the most common that we're going to be working with. So anything else we'll just name as an n-gon, where n is the number of sides. All right, looking at this, the interior angles and number of sides. Basically, the interior angles of a polygon are the angles on the inside of the polygon. So they're on the inside of the polygon. And n stands for the number of sides. So if our polygon, for example, has 1, 2, 3, 4, 5, 6, 7, 8 sides, this is an octagon, it will have the same number of angles. So 1, 2, 3, 4, 5, 6, 7, 8 angles. So the number of sides will be equal to the number of angles in the polygon. Key here is our interior angles are on the inside of the polygon. The polygon exterior angle theorem states that the sum, keep in mind, is not one interior angle, but all of the interior angles added up. The sum of the interior angles of a convex n-gon is equal to S sub I, so S standing for sum, I standing for interior, parenthesis n minus 2 times 180, where n equals the number of sides. So anytime we want to know the sum of the interior angles of a convex polygon, we're going to do the formula S sub I equals n minus 2 times 180. You should be able to find that on your calculator MCHS math program as well, so feel free to look for that later today while you're working. Example 1 says find the sum of the angle measure in a polygon, and we're going to do that by looking at this convex hexagon. So a hexagon, we should know, even without the picture, that hexagon really just means that n is equal to 6 sides. Convex, we've seen this word a couple of times already. I'm just going to draw a little side note, so this would be something for your annotations. We have convex and we have concave. So a convex polygon versus a concave polygon. Concave looks like this. So if you notice, this particular polygon from this vertex to this vertex caves inward to itself. So that would be a concave when it caves in. Whereas convex, all of the sides are pointing outward. So for example, here's a pentagon, but it's convex because everything is outward. So when you see that word convex versus concave, that's what they're talking about. Now the key is we're not finding one angle, we're finding the sum of the interior angles. So we're going to start with the formula that says S sub I. Sum of the interior angles equals n minus 2 in parentheses times 180 degrees. So S sub I is equal to, in this case, 6 minus 2, because 6 is the number of sides, times 180. Go ahead and evaluate that. I'll give you a moment to pause your video and find that value. Okay, you should have found, if you look at my next couple of steps, you should have found that the sum of the interior angles of a hexagon is 720 degrees. So that means all convex hexagons have a sum of 720 degrees for all of the interior angles. So all 6 of these angles should add to be 720 degrees. Okay, example 2. Now we're going to find the number of sides of a polygon. So we're going to work backwards in this example. It says the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. So from that first sentence, I have established that the sum of the interior angles is 1,260 degrees. It says to classify the polygon by the number of sides. So in this case, what we're looking for is how many sides this polygon will have. So we're going to use the same formula that we just used a moment ago in example 1. But the way that we use it is going to be different. Now, with any of these problems, when you're using a formula, you are required to show the formula, and when you practice that, you'll need to show the formula then as well. That'll just help us to make sure we're using the correct formula and to make sure that we have it practiced and memorized by the time of our assessments. All right, in this case, we don't know n. We instead know S sub I. S sub I standing for the sum of the interior angles. So in my equation, I'm going to replace S sub I with 1,260. That was what was given. And that equals the number of sides minus 2 times 180 degrees. So now we're just going to go ahead and use algebra to simplify this. There's a couple of ways you could approach it. You could start by distributing the 180, or you could divide by 180 as well in the beginning. That's really up to you. I find most students like to distribute first. So here's what that will look like. 180 times n would be 180n. 2 times 180 would be minus 360. Now go ahead and pause your video and solve this equation for n. Okay, you should have found n is equal to 9. If you did not, please pause the video again and look back at my steps algebraically to see where your mistake might have been. And if you still can't figure out what that is, please let me know tomorrow in class. So we found n is equal to 9. But if you look, it says to classify the polygon. Classify the polygon by the number of sides. So really what that means is we're supposed to name the polygon. Well, this is a 9-sided figure, which means it's a nonagon. And we found those at the beginning of our notes. So basically what that means about this shape is any nonagon, any 9-sided figure, will have a sum of an interior angle equal to 1,260 degrees. All right, example 3. Find an unknown angle. So now what we have here is they've given us a quadrilateral. I know that because it's 4-sided, and we need to find one of the unknown angles. In this case, they called it x. So the first thing we need to know is what these angles should add to be. We're going to go back to that same formula, s sub I equals n minus 2 times 180 degrees. Now if we simplify this by plugging in 4 for the number of sides and evaluating algebraically, we're going to find that s sub I is equal to 360 degrees. Now, in the past, you learned that all triangles, the angles in all triangles will add to be 180. Well, the same thing is true here. The angles in all quadrilaterals will always add to be 360. So this is something you'll want to put in your annotations, that the sum of the interior angles of any 4-sided figure is equal to 360. You should know that as a fact, as opposed to having to evaluate this every time. Now we're not done. We've simply found that the sum of the interior angles is equal to 360 degrees. We still need to find x. Well, if all of these angles equal 360, that's the equation we're going to make. X plus 108 plus 121 plus 59 equals 360. Keep in mind, if this had been a 5-sided figure or a 6-sided figure, this 360 would change. So our first step is to find the sum of the interior angles based on the number of sides, and then our second step is to set the interior angles added together equal to that total. Now we're going to solve this algebraically. Well, if we add together the 3 interior angles we were given, we are going to find that 108, 121, and 59 all add to equal 288. So the 3 known angles make up 288. Now we're just going to proceed and solve this by subtracting 288 from each side. So 360 degrees, the sum of the interior angles, minus 288 is equal to 72. So in this case, x is equal to 72 degrees. And that is our final answer. All right, so exterior angles theorem. The exterior angles of a polygon are the angles on the outside of the polygon. The sum of the exterior angles in every polygon is always equal to 360 degrees. So the one thing you want to be really careful of with the sum of the exterior angles, we'll write it as S sub E, sum of the exterior angles, for every polygon is 360 degrees. Now, if you look at this formula, it is not dependent on n. So you need to be aware that. So when we look at this, it does not matter if this is a 3-sided figure, a 5-sided figure, a 10-sided figure. The sum of the exterior angles will always be precisely 360 degrees. So let's take a look at example 4. Example 4 says to find the unknown exterior angle measures in the figure. Now, when we used the sum of the interior angle measure to work through a problem like this, we had to first calculate the sum of the interior angles. We don't have to do that here because we know the sum of any polygon's exterior angles will always equal 360 degrees. So that's just a known fact. Now what we need to do is use the 4 angles. We have the 2x, we have an 89 degree measure, we have a 67 degree angle measure, and we have an x degree measure. And those exterior angles for any polygon will be 360 degrees. Go ahead and pause the video and show your work to solve this equation. Okay, if you take a look, you should have found x to be 68. If you did not, please pause the video again and work through the steps that I've shown and see if you can find your mistake. So if we look at this carefully, it says to find the value of each angle in the diagram shown. So the angles are 89 degrees, that was given, 67 degrees, and then this value that's just plain old x is the same as what we just calculated x to be, or 68 degrees, and then our final angle is 2 times x. So we would just simply do 2 times 68, or calculate that to be 136 degrees. All right, the last example says to find the angle measure in a regular polygon. The trampoline shown is shaped like a regular dodecagon. Find A, the measure of each interior angle, and B, the measure of each exterior angle. Okay, there's 2 things you need to know about this. First of all, it's regular. That means all equal sides and all equal angles. If it was not regular, we could not do this problem. The second is that it's a dodecagon, which means n is equal to 12. So if we look at this, if n is equal to 12, we're actually going to start by finding the measure of each exterior angle. Well, if the sum of the exterior angles is equal to 360, and there are 12 equal angles, then 360 divided by 12 will tell us what each of those is. So each of those is 30 degrees. If you look at this, now we're going to find now we're going to find part A. Part A says to find each interior angle. Now, if you notice, I'm not using S sub I any longer here because I'm not looking for the sum. I'm looking for one angle precisely. So I stands for one interior angle and E stands for one exterior angle. One fact that you need to know is that an interior angle and an exterior angle are always going to be supplementary. So I found the exterior angle first to be 36 degrees. So the interior angle is just its supplement, or 180 minus 30 equals 150 degrees. So that would be the interior angle of that particular type of a regular dodecagon. Go ahead and try the You Try Nows, check your answers, and come with questions tomorrow. Have a good day.